Hi everyone, and welcome to this video going over lesson 18.2, interpreting the solution of a system of inequalities. Let's get started. For part A, it says determine the solutions to the systems of inequalities by graphing. So I'm going to go ahead and graph this first inequality, and I'm lucky that it's already in slope-intercept form because this tells me that my starting point is 2. And that my slope is 1 over 2, and so that tells me that I go up 1 and to the right 2 every time. So up 1 over 2, up 1 over 2. Or to go backwards, I would flip both directions, and so I would go down and to the left. So down 1 to the left 2, down 1 to the left 2. Because there is no line underneath my inequality sign, this means that my boundary line is dashed. And since the sign is opening up towards the y, this is saying that y is greater than. And so in order to shade where y is bigger, that means I would shade above the line. I then need to graph my other inequality, but unfortunately it's not written in slope-intercept form. So I need to rewrite it myself to solve for y. So the first thing I'm going to do is subtract x to either side, and I will be left with negative 2y is greater than negative x plus 8. I put the negative x in front because I'm used to the x term being first. And then in order to get y by itself, I'm going to divide everything by negative 2. So I'll be left with just y. And because I divided an inequality by a negative, I have to flip my sign. This is very important that you don't forget to flip your sign when necessary, because if you forget to flip your sign, you'll probably shade your inequality wrong. So make sure that if you multiply or divide an inequality by a negative, that you flip the sign. Moving forward, when I have two negatives, one on top and one on the bottom, they'll cancel each other out. And I have an imaginary 1 in front of x, so I can treat this as 1 over 2x. And 8 divided by negative 2 will leave me with negative 4. So negative 4 is my starting point. And my slope tells me that I go up 1 and to the right 2 every time. Or I can go down 1 and to the left 2. Because there is no line underneath my inequality sign, once again I have a dashed boundary line. And because the sign is opening up away from the y, this is saying that y is less than, and the less than y values are going to be below the line. And looking at this graph, it looks like my boundary lines are parallel. And I can tell this because both of my inequalities had the same slope. Parallel lines have the same slope. So if you ever see two equations or two inequalities with the same slope, you know they're going to be parallel. And in this case, the shading went away from each other. Notice how there's never a time where the shadings overlap. And so what this means is that this system has no solutions because there's never a time when the shadings overlap over one another. And because the shadings never overlap, there are no points that work for both inequalities, and so there's no solutions. Let's try another one. Looking at B, once again, I have to rewrite my inequalities. So for the first one, in order to get y by itself, I'm going to subtract 3x to either side. And I will have y is less than negative 3x plus 3. So this tells me that I start at 3. And remember, if we have a whole number slope, we can put an imaginary 1 in the denominator. And this will tell me that I go down 3 and to the right 1 every time. I don't have a line underneath my inequality sign, which means my boundary line is dashed. And because it says that y is less than, I shade below my line. For the other inequality, in order to get y by itself, I need to subtract 2 to either side. So I'll be left with y is greater than or equal to negative 3x minus 2. So this tells me that I start at negative 2, and I'm going to go down 3 and to the right 1. Or to go backwards, I can go up 3 and to the left 1. There is a line underneath my inequality sign, so that means that my boundary line is solid. And because it says that y is greater than, that means I have to shade above my line. And then I can see that my shadings overlap in between the two boundary lines. And so that means that this is where the solutions are to my system of inequalities. And if you actually notice, once again, I have parallel boundary lines because these inequalities have the same slope. But this time I have solutions because the shadings went towards one another. In the first example, I had parallel boundary lines, but the shadings went away from one another. So it's important to note that just because we have parallel boundary lines doesn't always mean we're going to have no solutions. It just depends on which way your shading goes. So keep that in mind for systems of inequalities. Parallel does not always mean no solutions. Now what I'd like to do is try a word problem. So Ray plays on Willow Glen High School's basketball team. Last week he scored all of his points from free throws and field goals, and he has forgotten how many points, but he remembers some facts from the game. Let F represent the number of free throws, and let G represent the number of field goals he made. Write an inequality for each fact. So it says that Ray scored fewer than 20 points. For those that don't know basketball very well, each free throw is only 1 point. So for every free throw, F, he makes 1 point. And then for every field goal, you get 2 points. So he gets 2 points for every field goal, 2G. And because he scored fewer than 20 points, we make the sign face towards the 20 because that's at most the amount of points that he made. So that's my first inequality. Then it says that Ray made fewer than 6 free throws. So we are using F to represent the number of free throws he made. And what this is saying is that F has to be less than 6. He made less than 6 free throws. And then they actually want us to make one more inequality. At most, Ray made twice as many free throws as he made field goals. That means that if we double the amount of field goals that he made, his free throws are at most that amount. So his free throws are at most double what he made in field goals. And now I have 3 inequalities to graph, and then I'm going to look for the solutions. If you notice, they've already designated that my field goals, G, is on my y-axis, and that my free throws are on my x-axis. This means we are going to treat free throws, F, as our x variable, and our field goals, G, as our y variable. So we have to solve each of our inequalities in terms of G, just like we normally solve our inequalities in terms of y. So starting with my first inequality, I am going to subtract F to either side, and I will have 2G is less than negative F plus 20. And then to get G by itself, I'm going to divide by 2 to everything. And so I'll have G is less than -1 over 2F plus 10. So this tells me that I start at 10 and I go down 1 and to the right 2 every time. And notice how I'm counting by 2's. So I start at 10 and I go down 1 and to the right 2 every time. This inequality sign does not have a line under it, which means it's dashed. And because the sign is opening up away from G, it means that G needs to be less than, so I'm going to shade below my line. So dashed and shading below. For my next inequality, all it says is that F is less than 6. I mentioned this a couple times in class, but if we ever had a line that was just x equals a number, that would look like a vertical line that goes through that number on the x-axis. Because all along that vertical line, x would be that value. So remember, we're treating f like our x value. And so if we have f is less than 6, this would look like a vertical line that's dashed going through 6 on the x-axis. And if f needs to be less than 6, I'm going to shade where the x values are less than 6, and that's going to be to the left of the line. So I'm going to shade in a different color, shading everything to the left of that line. And for my last inequality, I need to get G by itself. So I'm going to divide by 2. And I'll have 1/2 F is less than or equal to G. But since I'm used to the Y, or in this case G, being on the left side, I'm just going to go ahead and flip these two around. So this will look like G is greater than or equal to 1/2 F. And remember, if there is no number to indicate our starting point, that means that our starting point must be 0. So I'm going to start at 0, and my slope is telling me that I go up 1 and to the right 2 every time. So starting at 0, and going up 1 to the right 2 every time. There is a line underneath my inequality sign, so that means that my boundary line is solid. And because it says that G is greater than, I have to shade above the line. And I know it's a little chaotic with 3 different inequalities going on, but hopefully you can see that I have an area right here where all 3 shadings overlap. Those are the solutions to this inequality, and these represent possible combinations of free throws and field goals that Ray could have made. For instance, Ray could have made 2 free throws and 2 field goals. That was one possible solution. He also could have made 4 free throws and 6 field goals. Remember, we can also pick points that are on solid boundary lines. So for instance, he could have made 4 free throws and 2 field goals. But hopefully you get the idea that as long as we pick a point in the region where all the shades overlap, we find solutions that satisfy the system of inequalities. And if we have 3 inequalities, we have to look for the points where all 3 shadings overlap. I hope that you understand how we applied our knowledge of systems of inequalities to a real-world problem. Please let me know if you have any questions, and I will see you in class.